Live from the Moscone Convention Center in San Francisco, California, it's theCUBE at Oracle OpenWorld 2014. Brought to you by headline sponsor QLogic, with support from HGST, Violin Memory, and Mark Logic. And now, here are your hosts, Dave Vellante and Stu Miniman.
Welcome back to Oracle OpenWorld, everybody. This is theCUBE, our live mobile studio. We go out to the events, we extract the signal from the noise. We're here live in the QLogic booth. This is our 5th year at Oracle OpenWorld, and Stu and I are really pleased to have Mike Workman on, storage industry vet. Mike, welcome to theCUBE.
Oh, thank you very much, I appreciate it. I appreciate the opportunity. It ought to be a lot of fun.
So you look good having, considering that you've been basically locked down in an R&D lab for the last, well, better part of 2 years here, And, so, I want to start there. First of all, congratulations on the FS1.
Thank you.
It's got to be a little bit like giving rebirth.
Yeah, a little bit.
So talk about that. You've really been busy. We talked last year briefly at Oracle OpenWorld. You said, okay, I got to go. Got a lot to do. And clearly, based on the announcement, you guys have been busy. I was quoted actually as saying, it's like no array I've ever seen before. But let's start with how it came about.
Okay. Well, one of the things that we recognized when we looked at the flash array industry as it was emerging from the old style legacy arrays was that islands of storage were beginning to proliferate again. And what I mean by that is you would have a point product that had flash in it and flash only, and you'd have over here the legacy arrays. And the genesis of a legacy array is exactly was the HDD. So the plumbing of the array was built on the performance and feeds and speeds of an HDD. So that was wrong. What people tried to do for flash, and so what people tried to do is build like point products that would incorporate flash and exploit it. Unfortunately, what you end up with then is you end up with sort of your petabyte storage over here and your terabyte storage over here. Legacy arrays, flashpoint products, and of course the flashpoint products were very low on features and functions because they didn't have 5 generations of software that preceded them. They were new, right? But they felt that it was necessary to build that new architecture in order to bring out the attributes of flash that allowed people to exploit it for speeding up the data center. What we saw is those islands of storage is exactly what a general purpose array is not supposed to do. It's supposed to bring a workhorse to the data center that gives you the speed and power of flash and the economics of disk, any and all, and get rid of the islands, get rid of the point products, and that's what is the work. The work is to build an array that can exploit flash and bring you the economics that you need to do petabytes of storage in the data center. That's what took some time.
Yeah, and that's what's unique about the FS1. I mean, when I first saw it, I said, it's like a chameleon. It can be this, and it can be that, and I've never seen that before, but there are other flash options in the market. I can put flash inside, and there are all flash arrays. I wonder if you could sort of talk about that spectrum and talk about how you've gone about it differently.
Sure. Well, it's interesting. In the flash business, there's people refer to a hybrid array. And what that is a semi-disparaging
You're not a hybrid.
comment. We're not a hybrid in that sense. What people do today when they say hybrid array, it's a HDD Genesis with some flash put in. And that has with it the implication that it has the kind of performance that you see in an HDD legacy array. And I understand that. I mean, everyone in the industry did that in order to try to get flash into the data center.
Well, Mike, there are some companies that created what we would call a flash-first hybrid array just because the economics, it's tough to justify having that performance and putting all flash when I also need capacity.
Yes.
Really, there's 2 tiers of the market. I need performance, I need capacity, and there are solutions out there doing quite well that do both of those.
Okay, but there's a spectrum, so it starts with, let's call it the bolt-ons.
Yeah.
Right.
No, that's fair,
and
right?
True.
That's a natural progression.
Right, which was actually a good idea at the time, right? Hey, let's extend the life of this legacy array.
Absolutely.
And then there's guys that said, okay, let's build it as a hybrid, designed as a hybrid, okay? And then there's this new class. So
yeah.
So please, carry on.
So what we tried to do is build, and succeeded in with the FS1, is to build an architecture that is flash. It was built and designed for flash. And it's both scale up and out. Meaning that our 2-node array, if you remember the data that Larry showed in the keynote, if you compare it against EMC's...
Actually, we have that. Can you bring that up, Matt? Can you bring that chart up? Great. It's up. Okay, good.
If you compare it against EMC's Extreme I/O, a single 2-node building block on the FS1 can scale up to 173 terabytes. And yet it's less than half the price per terabyte. And it delivers between 20 and 50% more random I/O, and it delivers 8 times, 800% the 32K I/O, and it delivers 5 to 10 times the sequential data rate. And nobody thinks, I love this, nobody thinks that sequential is important with flash because they think of it as IOPS and latency, right? But every workload that everyone talks about has sequential work streams. Oracle database, redo logs. Redo logs are 30, 50K kind of average block size, and they're sequential writes. So if you're limited in the case of Extreme I/O to 600 megabytes per second, you can't even begin to compare the performance of an Oracle database running on Extreme I/O compared to 5.4 gigabytes per second writes on the FS1. And you can't even begin to compare on 11 gigabytes per second of reads. So what I mean is, this is a scale up and out architecture. So even 2 nodes eclipses the competition, and yet you can expand beyond that.
So it's interesting, I got to follow up on that. So it's interesting, so you guys are getting aggressive, I love it. You know, I want to back up a little. I talk to customers, all the time, and sometimes I'll say to them, what's your storage strategy? And they'll say, EMC for block, NetApp for file. I'm like, okay, that's a strategy. To your point, stovepipes, right? That's changing. People are starting to realize there's, other things out there. You're going obviously hard after Extreme I/O, even though it's not an which is an all-flash array. Your product is not an all-flash array. So why that choice? Just because you had performance of the system that you felt you could put up against that? I'm not hearing comparisons against the big base, which is VMAX. Talk about that a little bit.
We compare great against the VMAX or the VNX. The VNX is a hybrid array, a bolt-on, which is, it's respectable, it's a good machine. But the key thing is that neither of those machines were designed, and indeed you can see it in the strategic positioning of our competitors. They're not designed as their flash solution. They're bolt-on legacy arrays. The FS1 is designed to do the job of all of those machines. It's got the HA characteristics, the rich set of software that goes with it. It is multi-dimensional in performance. It does not just do random I/O, it does sequential I/O. It does not just scale out, it scales up. And it is obviously price effective. That price on that chart, which is hilarious, that price is for our top tier of flash. But you can get that kind of performance with our next tier down of flash. We have 2 tiers of flash, and that is 5 times less. 80% less, 1/5 the price of EMC's solution, which I think is just awesome.
Right, we got to dig into that price. We got David Floria coming on later. He's my pricing
Well, those are
expert,
list prices, so
okay.
you can always deal from there.
So
but,
that's good. So you took your list prices and their list prices.
And their list prices. We just do that. We don't try to
great.
guess what people's discounts are.
Yeah, right. Okay, good. Another follow-up on this chart.
Yeah.
It's very IOPS heavy. What about latency?
Latency is standard low latency of all flash machines, around 500 mics, and we go up. Huh?
Solid.
It's a solid latency, yeah. And as you go out, it obviously goes up. So it's the typical I/O response curve. We can tend to push ours a little bit further than other guys, but I think the latency comparison of this machine versus others is very good.
So again, I see this as the chameleon. It does a lot of different things for a lot of different people. Can we talk about some of the use cases?
Sure. Well, I was actually thinking of that question this morning, and I was trying to come up with, well, what's not a use case? I couldn't come up with one, but that's probably because, it's my baby. So use cases are obviously Oracle apps, Oracle database, but the ecosystem that we live in is not just Oracle. We may be at Oracle OpenWorld, but it's open. It is open, so we support AIX, we support HPUX, we support VMware, we support Microsoft Hypervisor, the whole range of hypervisors and operating systems out there. And with our machine, instead of paying extra for all of that stuff, it's built in. So the device drivers and multipath drivers and all that stuff is all free with the software.
So will you strategically go after those other bases, or is it more,
sure.
If you're into an Oracle account, you'll build a sales channel around that, or?
Our sales channel goes after that all the time, actually. And we have enabled them to do an extremely thorough job of going after everything that they can go after with this machine. We happen to have advantage in Oracle. I mean, that's kind of obvious. The whole conference is Oracle on Oracle, red stack, hardware, software engineered together. And I think it kind of goes, that's sort of for us, one of our main basic things, but the rest of it is the same. We have to go after all those platforms.
I want to come back and talk about that Oracle on Oracle and the hardware and software piece, but I know Stu's very interested in jumping in here. I'm dominating the conversation. I get a hold of guys like Mike, and I just want to keep asking questions, but please, Stu, go ahead.
Oh, all right, thanks Dave, I get to ask questions. So Mike, of course, the reason that infrastructure lives is to take care of the application, and we've been hearing from a lot of the storage players out there. They're talking about their affinity and how they work with applications, and I think back, the first time I heard a term, it was application-aware storage.
I like that
probably,
term,
when Pillar came out,
that's right.
long ago.
That was
of course, back then it was like, infrastructure is just going to be a platform and you put anything on it, and we've seen this progression. You were talking about when we understand, say the database, we can understand if we have, various I/O patterns to deal with that.
Right.
Talk about what you've seen in the last few years. Is this something that, Pillar was just really early and now the whole market's come around to? Where's that progression? Where are we with kind of the application affinity when it comes to storage?
Sure, okay. It's a good question because and we were very proud of the application aware thing. We did start that, and the idea of that was around the fact that each application in the data center, everything that you look at has peculiarities. It has certain kinds of attributes, salient features of the workload that are different than the other guy because of the way the engineers built the stack or used the hardware. Fine. It's important to extract performance out of a storage system by tuning it so that it works well with those differentiated work streams. And so application aware means that our storage is automatically tuned by provision, one-click drop-down, or a command line interface if you're so inclined, to immediately line up its attributes. For example, famous example, Oracle database. There's 7 LUNs in a particular database that are fundamental, and those content containers, very different workloads. If you look at the redo logs, they're sequential writes, and it turns out that you can do that really well with HDD actually, if you have a write-back cache, and we do, that's non-volatile. If you take a look at the databases and such, there's things like indexes that need to be on SSD, right? Because they're fast and they're very latency sensitive. So application aware has always been in the industry in terms of the concept that you have to tune the storage to meet the application, but what we tried to do is inculcate it so that the machine did the most of the work for you. But it's interesting because I had a question from an expert yesterday after one of my talks. He said, well, we like to tune the storage though.
Yeah, we love knobs.
We like knobs.
Yeah,
and I said, okay, how about this? What you can do is you can start from our tuning that we did, where we take the white paper and we wrote it so we could kind of implement with it, right? So we wrote the white paper, we put that knowledge into the setup, and then you can tune it from there. Just use this as a starting point, if you insist.
The starter kit, right? We automate the white paper.
But I think that the industry in general knows that, in fact, that's why you see islands of product. You'll see a solid state array for things that need to be fast, and then you'll see legacy arrays being employed for things that don't need that latency, right? Well, that's fine, except what we tried to do is say, you don't need to build islands of storage again. We don't need to go back to that again. Let's pull it together. Let's put this thing into a workhorse mainstream array that has the performance that meets those flash expectations, that has the manageability from people that just want to click a mouse button and have it set up for them, all the way to ones that want to tune knobs.
Mike, a lot of companies are using data reduction techniques directly within the arrays, particularly popular with all flash arrays because it's so expensive. Talk about your data reduction strategy, how it differs, and why you're choosing to go the direction you're going.
It's a good question, because you're right. I mean, if you look at our flash, just to buttress your point, if you compare Extreme IO, just as an example, $25,000 a terabyte for their flash, and that's what they have. That's it. We can go from $25,000 a terabyte, their analog, ours is $12,000, $11,000 a terabyte, but we also have a tier that's $5,000 in flash. So right there you get a factor of 2 or 4 in price effectiveness. That's pretty much the dedupe range right there. But if you want a tier to disk, you go down to $250 a terabyte, capacity disk. There's a long way between 25,000 and 250. 25,000 to 250 is a factor of 100. Nobody's compression or dedupe is going to get them from there to there. That's not happening. That's why it becomes important to tier, right? Our strategy, though, when it comes to, for example, everybody uses Oracle database and compression, our strategy is really simple. Would you put your money on a storage system guessing what the Oracle database is going to do next? Or would you put your money on the Oracle database that kind of knows what it's going to do next? And that's where we put our compression. We have HCC, comes with every machine, it's enabled, it's with the software package. You can go in multiple levels of compression depending on the age and the heat of the data, and go from no compression all the way down to 100x, which is far superior and timely to what you can do with a storage box trying to guess.
And you're, today anyway, locking out the competitors. You're the only one who can enable HCC on an array, right?
Yeah.
Is that right? I mean, that's correct, isn't it?
Well, our ZS product can do it.
Yeah, Oracle,
Yeah.
right. The ZFS guys do the same thing. So that's going to be interesting to watch how that plays out.
Yeah.
All right. So Mike, there's one segment of the market I wanted to get your perspective on. Earlier this year, Wikibon put out a market definition and a forecast of what we call server SAN. Many people are calling it hyperconvergence. Basically scale out architecture, but it's the compute and the storage scaling out together with the application living in the same container as the storage itself.
Right.
What's Oracle's take on that?
Well, I mean, I think we're the embodiment of that. We have servers and storage that work together, that scale, that connect from the front end of the infrastructure to the back end of the structure. We can scale up, we can scale out, and all while the machine is running. Perhaps I don't understand.
So right, we're not talking about putting them together a la and Exadata or a vBlock. We're talking about a single unit.
Oh, like an engineered system.
Well,
like Exadata?
I'd say like what VMware's doing with vSAN.
Okay.
What startups like Nutanix and SimpliVity and Scale Computing are doing.
Right.
Where everything's on x86 hardware already, but I have enough capacity in the nodes that I can run the storage and the application, and I remove the need for a storage as a distinct unit because I just have a system.
I think that's a valid point. We believe that's what Exadata does. Okay. We believe that Exadata is the database and the storage machine combined. And in fact, if you go to somebody like Gartner, they don't classify Exadata as being a storage machine. But the truth is it's a large part of it is a storage machine, and it's $1 billion a year business. And that storage comes from somewhere. And so there's storage, compute, with the application built together. Exalytics is that, etc. Supercluster is kind of a more platformish type application of that, but containing storage, and then in that case, anybody's application running in that. So Mike, I think we do that, but maybe different, couched in different terms.
Had a question from the crowd. Somebody wanted to know what OS, what storage OS is the FS1 based on? Is it the Pillar OS? Is it a new OS? Is it a combo?
The OS that runs in the machine is Oracle Linux. The software is 5 generations of software ported to run in this new architecture that was designed for flash. So it's sort of one of the jobs that we had was to preserve all that rich suite of software tools and functions and put it in the FS1, at the same time replumb it so that we could be an all-flash array.
Okay, great, that's good, thank you. And now, your role, Senior Vice President of Storage, what does that mean? There's a lot of storage popping up, right? So, you run all storage?
Well, I run the flash storage machine group.
Okay.
So, it's essentially, it's morphed from the Pillar acquisition.
Yep.
And I was brought in to build this machine with my team. We've of course enhanced that, incorporated a lot of technologies from the various areas of Oracle, and built the FS1. And we'll see how that progresses over time.
Well, one of the things you got to love about Oracle is it spends money on R&D. Safra talks about, and you saw that with the ZFS line.
Yep.
She talks about the, NAS, Larry talks on the call, NAS grew this quarter.
Yep.
These other pieces didn't grow. SAN actually, recently has been down. You're the fix to that.
Yeah.
So what should we be watching for? What are the metrics that we should be looking at? What are the objectives that you have? I mean, you guys don't have a huge market share, even within your own install base. I got to believe that's one of the things that we should be watching in terms of progress. But to talk about maybe your goals for the business.
Where our goals are strictly to provide our customers with price and performance advantages if they're running RedStack. And if they are, it becomes a no-brainer that they want to use our infrastructure. That's our servers and our storage, whether it be NAS or SAN, whether they be Solaris or their Linux, or whatever. We want our hardware infrastructure to be the infrastructure of choice, and I think that you'll see that start to happen more and more and more.
Excellent, that was Mike Workman dropping some storage knowledge here, right here live on theCUBE. Awesome to see you again, really appreciate your time. Industry vet, and always a pleasure, Mike.
You guys
Thanks
are fun,
so much.
thank you.
All right, keep it right there, everybody. We'll be right back after this word.